remember, you may want to sit where you can see those two monitors because this is not working. All right, we'll go ahead and get started. So they still have an issue with one of the monitors. Hopefully they'll get it fixed for next Wednesday. Make sure you're continuing to work on your new Algebra assignments. Now, some of you have completed the quiz. Remember, there are 2 attempts. So take the first attempt, study it if you need to, and then take the second attempt. And it'll take the better of the 2. And I think the deadline is the 17th for that. And we're almost finished with the section that's going to be on quiz 2. So that's why you got to work on quiz 1, because right after that, in about a week, is quiz 2. So try not to fall behind in your work. And I did extend quite a few assignments till tomorrow. But I can't extend it any further because you're getting more sections to study. And so you can just keep falling behind. You can drop half your worksheets. So if you don't get to it, study it still for a test or a final or a quiz, but you got to move on with it. Okay? Don't keep falling behind on these worksheets. Okay, so what I want to do is, and this is a short week. I purposely made this a short week, as you saw in Canvas, in the messages I've sent you. That this is a short week for the purpose of getting things done from week 2. So some of you still haven't finished week 2, and we're in week 4. So I made this a short week, and after this week, I can't make them short weeks anymore. We have to continue on with the work. Okay, so what I want to do is, today we're going to look at some examples on the section on rational inequalities. Okay, so rational inequalities, that's what you have to study on Monday. So Monday was rational inequalities. So rational inequalities. It is not a difficult section. If you've been working on the section on quadratic inequalities, then this is the same process. Same process. So let's kind of review a quadratic inequality. So there's going to be a review. All right, solve the following. Quadratic inequality. All right, so here's the first one. We have x squared plus 5x is greater than or equal to 14. All right, so you're going to have this on test number 1 in a couple of weeks. And you are going to have this on quiz number 2. So on that particular problem, what's the first thing you have to do? You got to get 0 on one of the sides. So let's go ahead and bring the 14 over. So we have x squared plus 5x is, minus 14 is greater than or equal to 0. All right, now you got to remember your steps. What's the next thing you have to do? Okay, why are you factoring? What are you trying to find? You're trying to find those zeros, the critical values. All right, so let's find the zeros. So to find the zeros, because those are the zeros you're going to put in the number line. So the zeros, to find the zeros, you're going to take the quadratic expression, and you're going to set that equal to 0, and you're going to factor. They're all factorable. The ones you're going to have are factorable. So when I factor this, I get x, let's see, that'll be what? X plus 7 times x minus 2 is equal to 0. So that's how you factor this. And then you remember the zero factor property says you set each factor equal to 0. So I get x plus 7 is equal to 0. X minus 2 is equal to 0. So in the linear equation, x plus 7 is equal to 0. When is x plus 7 equal to 0? When x equals what? Negative 7. And over here, that's when x equals 2. So those are your zeros. Those are your zeros. And sometimes they're called the critical values. Once you find the zeros, what do you do to them? Put them on the number line. And you make sure you put them in order. So negative 7, 2. Now when you do your worksheet, and some of you turned in the worksheet already, and you didn't even look at any of the videos that we did. You didn't even do it like this. You did it in a way that makes no sense. So whenever you're doing the worksheet, don't just jump to the worksheet. You got to look at the videos, especially if you're not comfortable with that kind of problem. So on the worksheet where it says show appropriate work, that's what I'm looking for. I'm looking for those zeros. I'm looking to make sure you put them on the number line. Now, once you put those zeros on the number line, what is the next step? Say it again. Test points. So notice that these two zeros divide the number line into 3 intervals. So you're going to pick any number between any of those intervals. So in the first interval from negative infinity to negative 7, give me a test point. Give me a number in that interval. Huh? Negative 8. And put the test points in parentheses so I know that those are your test points. And then give me a test point between negative 7 and 2. And it's always nice to use integers. You can use any decimal you want in there, but it's always easier to use an integer. Like negative 8 is an integer. 0. 0 is always an easy one to use. And then give me the last test point in the interval greater than 2. Huh? 8, okay, you can use 8. 8's in that interval. All right, the purpose of finding those test points is to determine whether these intervals here are solutions to this inequality. So when you're solving an inequality or solving any equation or inequality, it doesn't matter whether it's an equation or inequality, when you're solving that equation, or in this case, this inequality, you're trying to find the values of x that will make this inequality a true statement. So I want the values, I want the left side to be greater than or equal to 0. What kind of numbers are greater than 0? Positive. So I want to find all the values of x that will make this expression positive. But there's an equal sign. So I want the value of x to make it positive, or it could equal to what? 0, because of the equal sign. So positive or 0. All right. So right away, now there's in these cases there are going to be an infinite number of solutions. But right away, I know 2 of the solutions. Your zeros, right? Why is this and this a solution to this inequality? Why is that I'm going to put a closed circle on both of those to indicate that those are solutions? What do you think? Huh? Because of the equal sign. Equal to 0. Okay, now you got to determine whether negative 8 makes this interval right here positive or negative. And all you do is go back to the factored part. So I'm going to go back and rewrite this. I'm going to rewrite this right here. I'm going to put x plus 7, x minus 2, greater than or equal to 0. It's always easiest to substitute back in the factored part. All right, and then we're almost done. The rest is easy. So you're going to take -8, and wherever you see the variable x, you're going to substitute -8. How many factors do you see on the left side? How many factors do you see on the left side? Huh? What do you mean? Well, when we factored this trinomial, what did you factor it as? Tell me what when you factored it, factoring means to write a product of factors. So when I factored it, what did I factor it as? Can anyone tell me how we factored this quadratic expression right here? What are the factors? Huh? Say again? No. Those -7 and 2 are your zeros. I'm asking, what are the factors? Last year, when you started factoring you wrote as a product of zeros. What am I multiplying together? What am I multiplying together right here? Tell me what's in parentheses. That's a factor. X plus 7 is a factor. What is your other factor? X minus 2. That's what factoring is. You're writing as a product of factors. So when you factor a polynomial, what you end up in parentheses are your factors. It's kind of like saying if I had the number 8 and I wrote 8 as 4 times 2. What that means is that 4 is a factor of 8. 2 is a factor of 8. That's what that means. So when I rewrite this quadratic expression right here as a product, those are your factors. And so when I substitute -8 into this left-hand side, I'm going to use the factors. All right, so there are 2 factors right here. So I'm going to substitute -8. So when you do this worksheet, if you haven't done it already, it's due tomorrow night. Where we see the variable x, you substitute -8. So I get -8 plus 7 times -8 minus 2. That's that first interval. And then all you do is determine the sign. What's -8 plus 7? What kind of number? Negative. It's a -1 in it. Times. What's -8 and -2? What kind of number? Huh? Negative as well. It's a -10. What's a negative times a negative? Positive. So that means that any number in that interval from -infinity to -7 is going to make this inequality, this expression on the left side, a positive number. So is that interval going to be a solution? Yes, because I want it to be positive. Now let's go to the next interval. What's my test point in the next interval? 0. Okay, 0. So wherever I see the variable x, what do I substitute? 0. So I get 0 plus 7 times 0 minus 2. What's 0 plus 7? Positive, right? What's 0 minus 2? A negative. What's a positive times a negative? Negative. So what does that mean about this interval? So any real number in this interval will make this, and go ahead and circle it in red, will make this quadratic expression what kind of number? Negative. Is that something I want? No, I want that to be what kind of number? Positive. So this is going to be negative. Any number in here will make this negative. So that's not, when I exit out, I don't mean it's wrong. So be careful when I put x there. Remember what I implied before in those videos in the last lesson and the last class period and today is that that's not going to be a solution. Let's see. David, can you hear me? The other class, previous class couldn't hear. Just in chat, just say yes or no. Okay, thank you. All right, now let's go to 8. So for 8, where we see the variable x, we substitute 8, so I get 8 plus 7 times 8 minus 2. What kind of number is 8 plus 7? Positive. It's a positive, what's that, 15? What kind of number is 8 minus 2? Positive. Oops, let me put positive there. It's a positive 6. A positive times a positive is a what? Positive. So that means that this interval from that's greater than 2, any real number there is a solution. And so you're done. All you got to do now is just write the answer interval notation. So the answer is going to be, and how many intervals do you see that are going to be solutions? 2. All right. So you're going from here to -7. So you're going to say negative infinity to -7. Now, am I going to use bracket or parentheses at -7? Bracket. Why bracket? Because of the equal sign. And make sure it looks like a bracket. And then union, and then what's the other interval? What are you going to write? Bracket 2, comma, infinity. And remember, infinity, negative infinity, always use parentheses. And that's it. So that is the work you're going to show. And it's got to look like that. You can't show any other work. Some of you are turning stuff in and you're doing all kinds of stuff and it's not making any sense. How are you getting what you're doing to the answer? You're not showing me anything. So if you can do this, then you'll be able to do rational inequalities. So there are 2 worksheets due this week. One on rational inequalities and the other one absolute value equations. And they both due Sunday. So you still have some time to work on those. So let's look at a rational inequality. All right, rational inequality. And the ones we're going to look at are fairly easy. And when I say easy, I mean easy in this sense. They're going to look like this. X plus 8 divided by x minus 3 is greater than or equal to 0. So when I say they're easy, what I mean is that the expression on the left-hand side is a fraction, just one fraction. You don't see any other fractions involved. It's just one fraction. So remember a rational expression from a previous course, a rational expression. And for us, we're looking at polynomials. So it's a polynomial divided by another polynomial. So the x plus 8 and x minus 3 are considered polynomials. They're linear expressions. And those so that's how they're all going to look for us in this course. They're going to look like that. Now, just to let you know, in maybe another course, you could see something like this: x plus 8 divided by x minus 3 plus 5 is greater than or equal to 0. So you see, now you have how many fractions? You have 2, because you can think of 5 as 5 over 1, right? You have 2. But for us, we're only going to be dealing with just a rational inequality that's just one fraction on one side. So solving this is a little bit more involved, by the way. You still have to get 0 on that side. So you got to deal with the fact that 5 is there. So it's a little bit more involved. So let's go ahead and look at number 1. I'm going to rewrite it over. X plus 8 divided by x minus 3 is greater than or equal to 0. Okay, so there are some steps you're going to follow. And David, the steps, if you go to Canvas, the steps are right under the lessons if you go to Canvas. The rest of it, I did make copies of the steps for these, if you want a copy. All right, now, when we do this, remember, when submitting that worksheet, when you go to Canvas, and maybe you too, ooh, he's off. Nope, he's back on. When you go to Canvas, and you go to get that worksheet, there's a resource there as well. It says this is what the work should look like. Make sure you're using it. All right, so I'll put things in there so that way you know what it is you need to be, what it should look like if you want your points. So whenever you see this is what the work should look like, you need to use it. Okay, so on your worksheet, you're going to do your worksheet problems just like we're doing these. All right, so step number 1 is to factor both numerator and denominator. Just like you did a while ago with the quadratic expression. So if you look at this, though, the numerator is x plus 8, and the denominator is x minus 3. Those are linear factors. You can't do anything else to this. So step number 1's already been done. There's nothing to do, rather. Now, step number 2 is this. So this is where you can look at the numerator, and you can look at the denominator, step 2 and 3. Numerator and denominator. So step number 2 says you got to find the zeros of this rational expression. Okay? So when finding zeros, just to let you know, so what I'm going to write in blue is not the work you're going to show, but that's just extra expression, explanation. So and it's in the videos as well. So when you're finding the zero of a rational expression, you're going to take that rational expression, in this case it's x plus 8 divided by x minus 3, and you're going to set it equal to 0. That's what it means. What value of x makes it equal to 0? That's what it means to find the zeros. And on day number 1, you learn how to solve this kind of equation. How do you solve this rational equation? You have rational equations day number 1. What'd you do? Equal. You can multiply both sides by the least common denominator. What's the least common denominator? X minus 3. So you multiply both sides by x minus 3. What you do to one side, you do to the other. And so when you multiply both sides by x minus 3, the x minus 3's divide out. And so 1 times x plus 8 is x plus 8, and that's going to equal, and then 0 times x minus 3 is 0. And here's the point. That last statement I just wrote, this x plus 8 equals 0, where does that x plus 8 come from? Which part of the rational expression? The numerator. So that's what step number 2 says. So step number 2 says, find the zeros, find the zeros. Well, the zeros are going to come from the numerator. Because when you set a rational expression equal to 0, in our case, it's going to be one fraction, and you multiply by the LCD, that denominator cancels out. You're just left with the numerator. So you don't have to do that. Don't do the blue work. You're just going to do what's in black here. So you're going to say x plus 8 equals 0. And so if x plus 8 equals 0, what is x? What is x? Negative 8. So there's your 0. Okay, now, step number 3. That's where the denominator comes in. So you got to find out next, where is this rational expression undefined? Where is this rational expression undefined? Well, remember, a rational expression is undefined, so this is going to be blue. A rational expression is undefined when the denominator is 0. So rational expression defined when the denominator is 0. It makes sense because all through your life, you were always told that 7 divided by 0 is undefined. You cannot divide by 0. Now, be careful. What is 0 divided by 7? 0. That's 0. So a fraction is undefined when the denominator is what, though? 0. So in step number 3, to find out where this rational expression is undefined, you just look at the denominator. Oops, let me put that in black. So the black will be your work. So undefined point, we call that the undefined point. Undefined point. So to find the undefined point, you take the denominator and you set that equal to 0. And so when is x minus 3 equal to 0? When x is what? 3. And so those are the two numbers you're going to put in the number line. So it's a little bit, this part here is a little bit different than the quadratic inequalities that we did. Because those are called zeros. Here we have a 0 and an undefined point. All right, so the rest of this is like we did last week and in that first example we did. So you're going to put that on a number line, just like this, put it in order. So what are you going to put first? What number? -8. And what are you going to put next? 3, right? So those are the numbers you put in the number line. And now the next step is for you to find test points. So those two numbers divide the number line into 3 intervals. So you got to find out. Now remember our quadratic inequality a while ago. You have to find out what values of x will make this expression what kind of number? Positive, because greater than 0, or it could also be equal to what? 0. So positive or 0 because of the equal sign. Okay? Now before we go and start using test points, here's what I would do next. I would determine those two numbers that we just put in the number line. I would determine which one is not a solution and then which one is a solution if possible. So here's the thing I'm pointing out. The positive 3, this right here, that's the value of x that makes a rational expression undefined, right? It can never be a solution. Anything that makes the denominator 0 is never a solution. Okay? So since this is the undefined point, this 3, then that automatically is going to be an open circle. Because it's never going to be a solution. Anything that makes the denominator 0 is never going to be a solution. Now, what about the number -8? Is that a solution? And if so, tell me why. If not, tell me why. Is -8 a solution? Yes. Why is -8, do you think, is a solution? In fact, -8 is how we found the 0, right? Right here. The word 0 is -8. So what that means is that a value of -8 makes this rational expression 0. Is that something I want? Yes, because of the equal sign. And look, if you go back and you check it, I want to show you something. So if you go back, let me go and do it here. So you have x plus 8 divided by x minus 3, right? So I'm going to substitute -8 in there. I'm going to show you that 0. We have negative 8 plus 8 divided by negative 8 minus 3. What's negative 8 plus 8? 0. What is negative 8 and a negative 3? Negative 11. What's 0 divided by negative 11? 0. And that's what I wanted it to equal. All right. So since negative 8 is a solution because of the equal sign, I'm going to put a closed circle. Oops, let me put it in black. We'll put a closed circle there. All right. So negative 8 solution because of the equal sign. 3 is not a solution because it's that undefined point. Anything that makes the denominator 0 can never be a solution. And if you look at that last statement, that note at the bottom, it says the undefined points will always have open intervals, while the zeros depend on the equality sign. So for the zeros, you ask yourself, do you see an equal sign or not? So here I saw an equal sign for the 0. So negative 8 is going to be a solution. If there was no equal sign, what would you put on negative 8? Open circle. And then the rest is what you've been doing for practice this past week. You're going to use test points. So give me a test point in this first interval. Negative 9. Give me a test point in that second interval. 0, okay. And what about the third interval? What? 5, okay. So you could choose any number, any real number, any fraction, any decimal, any real number in those intervals. It's always easiest though to use an integer. All right, and then just like you did with the quadratic inequalities that you worked on, you're just going to take those test points and substitute it back into that expression. So let's do negative 9. So I have negative 9 plus 8 divided by negative 9 minus 3. So wherever I saw the value, the variable x, I substitute negative 9. And just like before, you're just basically determining the sign. So the numerator is going to be what kind of number? Negative 9 plus 8. What kind of number is that? Negative. It's negative 1. Divided by the denominator, negative 9 and negative 3 is what kind of number? Negative. It's negative 12. And what's the negative divided by negative? Positive. So that means that any number in this interval right here, is going to be positive. Well, when I say positive, I mean it's going to make that expression positive. That's what I meant. So any real number in that interval is going to make that expression I have circled positive. So is any real number in this interval going to be a solution or not? Yes, because I wanted this to be positive, greater than 0. So I'm putting a little check mark here to make sure I include it. Now we go to the next interval. What's the test point in the next interval? 0. So you go back, and where we see the variable x, you substitute 0 this time. So 0 plus 8 divided by 0 minus 3. What's the numerator? What kind of number is the numerator? 0 plus 8. Positive. What kind of number is the denominator? 0 minus 3. Negative. What's a positive divided by negative? Negative. So what that means is that any real number between negative 8 and negative 3 will make this expression I have circled a negative number. So is that second interval going to be a solution or not? It is not going to be a solution, because I want these real numbers here to make that interval positive. To make that rational expression positive. And then finally, we're almost done. The next test point is 5. So you're going to say 5 plus 8 divided by 5 minus 3. 5 plus 8 is what kind of number? Positive. It's what? Positive 13. 5 minus 3 is a positive 2, so that's positive. A positive divided by positive is what kind of number? Positive. So any real number in that third interval will make that rational expression I have circled a positive number. Is that third interval going to be a solution? Yes. And then next step is to write your answer as an interval notation. So what's your solution? What are you going to write? Huh? Negative infinity to negative 8 with a bracket because of the closed circle. Union, and then what? What kind of, I'm sorry, what was? Parentheses, good, because of the open circle. 3 all the way to infinity. And that's it. So the black, the stuff I have in black is the work we need to show. Okay? All right, so let's look at another one. It's really not that bad. The more you do, and if you really studying those videos, some of you go directly to those worksheets and try the best you can, and you struggle. So look at those videos. All right, so this is number 2. Number 2, let's suppose we had this. X minus 5 divided by x squared plus x minus 2 is less than 0. So x minus 5 divided by x squared plus x minus 2 is less than 0. So we have this rational equality, and this is the easy kind because all you see on the left side is just one fraction. You don't see any other fractions. So you have the easy kind. We're doing the easy kinds here. So step number 1 says to do what? Factor. Is there anything I can factor, either the numerator or the denominator? What could I factor? In number 1, I couldn't factor anything. What can I factor in number 2? Say it again. The numerator or the denominator? Denominator is quadratic. So I have x minus 5 divided by, and then in the denominator, the 2 binomials will be x plus 2, x minus 1. X plus 2 times x minus 1. And then that's less than 0. Okay? And the rest is very easy. The rest of this is very easy. So step number 2, you're going to find your zeros. Well, where do the zeros come from? The numerator. Well, the numerator is just this linear factor. So to find the 0, you're going to say x minus 5 equals 0, right? And so if x minus 5 equals 0, what does x equal? Positive 5. So there's your 0. So that's one of the things you're going to put in your number line. Then we do the denominator. So step number 3 deals with the denominator. So step number 3 is where you're finding what makes this rational expression undefined. Well, this rational expression is undefined. Notice my words, is undefined when the denominator, and what's my denominator? The factor, go and use a factored part. What's my denominator? Tell me, read the denominator, read it to me. X plus 2 times x minus 1, and you set that equal to 0. So when you set the denominator equal to 0, you're finding the values of x that makes that rational expression. It was circled in red. That makes this rational expression undefined. And so when you solve on one of the worksheets the first week, you have to solve a quadratic equation. So once you factor it, what's the next thing you do with these factors? Set them equal to 0. X plus 2 equals 0. I don't know why it does that. X plus 2 equals 0. X minus 1 equals 0. So x plus 2 is equal to 0 when x equals what number? Negative 2. X minus 1 is equal to 0 when x equals what number? Positive 1. So those two numbers here that you see here, those are the values of x that makes that rational expression that I have in red undefined. All those goes on the number line. So how many numbers will I put on that number line? 3. And make sure you put them in order. So what are you going to put first? -2, okay. Then what's going to go next? 1, and then 5, right? And so now those three numbers divide the number line into how many intervals? 4 this time. So it's a little bit more work, but it's still easy to deal with. All right, now I'm going to pick test points. So give me a test point in that first interval from -infinity up to -2. -3, okay. Give me a test point that's in that second interval. 0. 0 is always an easy one to use. What about 1 to 5? 3, okay. And what about that last interval? 6, okay. All right. So circle the test points in the test points. Put the test points in parentheses so I know that those are your test points. And then and so now, before we put the test points back into the expression, let's talk about those numbers I just put on the number line, -2, 1, and 5. Let's determine whether they're going to have open circles or closed circles. All right, and so David's the only one here I see. I don't know where that 4 comes from. There's a 4 over there, but I only see one. Oh, there are 2. Trey Lynn is also here. Okay, so let's talk about -2. Is -2 a solution? And then those of you online in chat say yes or no. Is -2 a solution to this inequality? David says yes. All right, and then I forgot your name. Huh? George? Okay, George says no. All right, David, you can't speak, I don't think. So George, why do you say no? That's what made it undefined, David. -2, see right here? -2 is your undefined point. That's what made it undefined. Undefined points can never be a solution. So at -2, what are you going to put? Open or closed circle? Open. Okay, let's talk about 1. The next number that we put on there, 1. All right, David, let's see what you're gonna say about 1. Is 1? Say yes or no. Is 1 a solution or not a solution? He says yes. All right. So I wish David could. I wish they had the ability to speak. What about y'all? What do y'all think? No, David, it's no. It's positive, right? I'm not sure what you mean by positive. So remember, -2 and 1 are undefined points. Undefined points are never solutions because it makes it undefined. So 1 is not going to be a solution because it's an undefined point. So undefined points are never solutions. All right, now let's look at the next one. The next one was 5. Now 5 is not an undefined point. Lynn and David. 5 is not an undefined point, right? So is 5 going to be a solution? Say in chat, say yes or no. Lynn, you can put yes or no also. Is 5 a solution? Yes or no? I think David wants to give up.
I know that it's not. I can't remember why. I know that it's a.
All right, David says yes because it's, and he stopped. I guess he's still writing. Let's see what he says. Yes, because In the numerator, okay? It did come from the numerator, that is true. George, what are you going to say, yes or no? Okay, George says no, David. Let's see why. 5 did come from the numerator, but George, why is 5 not a solution? Because there's no equal sign. There is no equal sign. All right, George, you're doing a very good job. So it's going to be an open circle. All right, David? Okay. David says he's got you. David says he's got you. Okay, I got you. All right. So they're all open circles. And whenever there's, first of all, just notice, I hope you notice this, whenever there's no equal signs, they're all going to be what? Open circles, right? There's no equal sign. They're all going to be open circle. When there's an equal sign, the zeros are going to be solutions. All right, and then now let's deal with the test points. So we have 4 test points. So let's do the first one. So -3, always go back to the one in which you have it factored. It makes things a lot easier. Always go back to the factor part. Now you got to make sure it's factored correctly, because then if what you have is not factored correctly, it's going to be wrong to begin with. You got to make sure it's factored correctly. All right, so we're going to take -3, and I want you to remember earlier I asked you how many factors do you see altogether? How many factors are in that numerator? Huh? How many factors in the numerator? Come on, guys. How many factors are in the numerator? Huh?
2.
No. Why are you saying there are 2?
1.
One is what?
1 in the numerator.
There's only one in the numerator. X minus 5, right? X minus 5 is a factor. How many factors in the denominator? 2. What are they? X plus 2, and what's the other? X minus 1. So altogether, how many factors do you see? 3. 1 in the numerator, 2 in the denominator. That's where these numbers came from, right? Those 3 numbers came from those 3 factors. All right, so you're going to substitute -3 in each of those factors. So let's do the numerator first. So the numerator, you have -3 minus 5. Okay? The denominator, in parentheses, you have -3 plus 2 times, and the second factor in parentheses is -3 minus 1. Okay. So wherever I saw the variable x, I substituted -3. Now the numerator, what's a -3 and a -5? What kind of number is that? Negative. It's a -8, right? Now the denominator, you have 2 factors, so let's do each one individually. What is a -3 plus 2? What kind of number is that? That's not a trick question. What's -3 plus 2? -1. So it's a negative number. Times, remember there are 2 factors in the denominator. So times, what's -3 to -1? -4, so it's negative. All right, now, the numerator is negative, right? Now let's talk about the denominator. My 2 factors in the denominator, they're both negative. So what's a negative times a negative? A positive. So my denominator is going to be positive. Altogether, what's a negative divided by a positive? Negative. And so what I found is that any real number in this interval will make what's in red, this rational expression, a negative number. Is that something I want? No? Why not? Why do you think you want what's in red to be positive? Huh? I can't hear you. You got to speak up. want that rational expression to be less than what? 0. What kind of numbers are less than 0? Negative. So you want this rational expression to be less than 0, and what kind of numbers are less than 0? Negative numbers. Earlier, we had a problem where, number 1, let me pull it down, this rational expression was greater or equal to 0. What kind of numbers are greater than 0? Positive numbers are greater than 0. So that's why you saw the word positive here. Here, that's a less than 0 expression. What kind of numbers are less than 0? Negative. Less than 0. Negative 1, negative 2.8, negative 5, negative numbers. So I'm going to ask you again. This first interval, and you two that's online, you can answer yes or no. That first interval, is that first interval going to be a solution to this inequality? Yes, because any real number from negative infinity up to negative 2 will make this rational expression a negative number, which is what I want. So put a little check there. Okay, now let's go to the next interval. What's the test point in the next interval? 0. So you can do the same thing. You're going to say 0 minus 5, the numerator, divided by, and in the denominator there are 2 factors. So you're going to say 0 plus 2 times 0 minus 1. Okay? What is the numerator? What kind of numbers are the numerator? 0 minus 5? Negative. So my numerator is negative. In the denominator, I have 2 factors. My first factor is 0 plus 2. What kind of number is that? Positive. My next factor, 0 minus 1. What kind of number is that? Negative. Negative 1, right? Okay, so my numerator is negative. Now my denominator, let's go about the denominator. That's those 2 factors being multiplied together. One's positive, one's negative. What's a positive times a negative? Negative. And what's a negative divided by negative? Positive. So what that means is that any real number in that second interval is going to make this inequality, this rational expression, a positive number. Is that something I want? Is that going to be a solution? No, that's not going to be a solution. So far, this one's a solution, that one's not. Now, one of the things I mentioned in the videos is that don't always assume this is going to alternate. Negative, positive, the next one's negative, positive, and so on. They don't always alternate. Now, you're going to learn in probably another course, you're going to learn when to tell if it does alternate or not. But don't always assume they will. Okay? So negative, positive. Now let's do the next one. 3. 3 minus 5 divided by 3 plus 2 times 3 minus 1. So wherever I saw the variable x, I substituted. In that case, it was, can't see it up here, 3. What kind of number is 3 minus 5? Negative 2. It's negative. 3 plus 2 is what kind of number? Positive or negative? Positive. 3 minus 1 is what kind of number? Positive or negative? What's the sign? Positive. Okay? So the numerator is negative. The denominator, the 2 factors are multiplied together. Positive times a positive is a positive. And what's the negative divided by positive? Negative. So what I found is that any number in that third interval will make this rational expression that I have read a negative number. So is that third interval, and David or Cameron, is that third trillion, is that third interval going to be a solution? Yes or no? David says, yes, I think. Is he correct? Yes. Okay. And then finally, the last test point, 6. So So in your worksheet, I don't think I gave you a lot of these problems because it is quite a bit of work you have to show. I think I may have given you 2 or 3 in that worksheet. So it's not difficult. Just make sure you show this kind of work. So 6, we have 6 minus 5 divided by 6 plus 2 times 6 minus 1. Okay, the numerator, what's 6 minus 5? What's the sign of that numerator? Positive. It's positive 1. The denominator, the 2 factors, 6 plus 2 has what sign? Positive or negative? Positive, it's positive 8, right? And then 6 minus 1 is 5, so that's also positive. So the numerator is positive. Now the denominator, those 2 factors in the denominator that I'm multiplying together, a positive times a positive is a positive. And what's a positive divided by a positive? Positive. So that interval, any real number in that 4th interval is going to make what I have in red, that rational expression, positive. So, or is that interval going to be a solution? No. And so therefore, how many intervals will be solutions? 2. So let's talk about the solutions. You always go from left to right. So you're going to do the first interval first that I have checked. So what are you going to write? Negative infinity to negative 2, union 1 to positive 5. Okay? So any real number in those 2 intervals is a solution to the inequality. So those are your solutions. So no other real number is going to be a solution. No, because 5 to infinity was positive, remember? And this is negative. Right? Okay. So it's just those 2 intervals that have the word negative. They're solutions. Okay, any questions? Okay. And that's all this is. It's not difficult. All right. So on your worksheet, there are, I think there are 2 or 3 problems on that worksheet. Now there's one that can, I don't think this is on the worksheet, but it could be on Newton Alta. And I want to just mention this, and this is number 3. Suppose I had 6 divided by x plus 5 is less than or equal to 0. 6 divided by x plus 5 is less than or equal to 0. That looks so much simpler than the others. But for some reason, students find this a little bit more difficult. Only the numerator part they find difficult. Because there's no x in there, right? You don't see a variable at all. Right, you still go through the process. Step 1 is to factor numerator and denominator. Well, the numerator is a monomial. Remember what a monomial is? See, that's 6 is a monomial, just one term. The denominator is a binomial. It has 2 terms. Can I factor the denominator? Can I factor the denominator? No. So step 1, there's nothing to do there. Step 2, remember, that's where you find your 0. So I'm asking you this. Okay, we find the 0, step 2. So remember, to find a 0, you take the numerator and you set that equals 0, right? So you take the numerator and you set that equal to 0. But remember, is 6 ever going to be 0? No, 6 is not 0. Those are 2 different numbers. So the variable, there's no variable there, right? There's no variable. So what that means is that there are no zeros. There are no zeros, so no zeros. So what that means is that this, I'm going to put it in red, what that means is that this rational expression is never going to be 0. it's never going to be 0. Because there's no variable in the numerator. What is the numerator always going to be in this case? 6. Your constant. It's a constant. It's always 6. Okay? It's never going to be 0. So there are no zeros. Now let's go to the undefined. Where is it undefined? How do I find that? You said that the denominator equals 0. Now that has a variable in it, right? So when is x plus 5 equals 0 and x equals -5? Okay? So we can put that in the number line. How many numbers do you put in the number line? Just one. What is it? -5. Now, remember, you always got to ask yourself, is that number put in the number line a solution or not? No. Because -5 makes that rational expression undefined, right? So I'm going to have an open circle there. And now how many intervals are you going to be looking at? 2. So you need how many test points? 2. So give me a test point that is in that first interval. -6. What about the other one? 0. All right, and the rest is easy. So the only hard part was that numerator, because there's no variable there. So that throws students off. If there's no variable in the numerator, then there are no zeros. There are no zeros. This expression is never going to be 0. So -6. So wherever I see the variable x, and how many times do you see the variable x in that rational expression I have circled? Just one. So I have 6 divided by -6 plus 5, right? The numerator is always 6. What kind of number is 6? Positive or negative? Positive. So the numerator is positive. In fact, it's always going to be positive because it's 6. The denominator, that's positive. The denominator, -6 plus 5, is a negative number. And what's a positive divided by negative? Negative. So any real number from -infinity up to -5 will make this rational expression a negative number. Is that something I want? Yes. Because less than 0 means what kind of number? Negative. R's, you see an equal sign, R's 0. So any number that makes it 0 is a solution as well. Now the next interval, 0. Where we see the variable x, we substitute 0. So I have 6 divided by 0 plus 5. What kind of number is the numerator, positive or negative? Positive, it's 6. 6 is always positive. The denominator is 0 plus 5. Positive. What's a positive divided by positive? Positive. So any real number in that second interval will make that rational expression that I have circled in red a positive number. So those numbers, is that second interval going to be a solution? No. So the only solution is this first interval. Now you see I have an equal sign, right? Have an equal sign, equals 0. So is any number going to be equal to 0 here? No, we said there were no zeros, remember? There are no zeros. So you're not going to have any close circle or brackets anywhere. It's all going to be open. So what's the solution? -infinity all the way to -5 with a parentheses. You may say, well, there's an equal sign there. Yeah, there's an equal sign, but there are no zeros. We saw that here. Zeros? There's none. There are no zeros. If there was a 0, then you put a bracket, but there are no zeros here. Okay? So on that worksheet, Just make sure the work looks like that. You do it just like I did to get full credit. All right. Now the next thing you have to do for Sunday is on, and this is an easy kind. This is easier than we just did, is absolute value equations. We're going to do absolute value inequalities the next week. So this is absolute value equations. So let's talk about absolute value equations now. All right, this is an easy kind. Okay, so let's start with a simple example, and always use this example in your mind when you're solving the kinds you have to deal with the worksheet. So in your mind, what I would think of is this: if I have the absolute value of x is equal to, let's say, 2. The absolute value of x equals 2. So that's what I mean by an absolute value equation. You have an equation with an absolute value symbol. So that's an absolute value equation. That's not linear. An absolute value equation is not linear. Because remember, linear is, what kind of graph is a linear function? It's a line, right? That's the graph of a linear function. An absolute value, and you're going to graph these soon, an absolute value has the shape of a V. That's what absolute value function looks like, the shape of a V. So an absolute value function is not linear. All right, so some students seem to think it's linear. It's not. The absolute value of x equal 2, that's an absolute value equation, not a linear equation. All right, so in your mind, I'm going to ask you this. So think about this. Well, first of all, do you remember what an absolute value of, let me give you this first. The absolute value of 4 is what number? You remember? 4. The absolute value of a number is the distance that number is from 0. Well, if this is 0 right here, and this is 4, what's this distance? 4. And we think of distance, you think positive, right? Okay, I'm going to ask you this. What's the absolute value of a negative 4? Huh? 4 also. The absolute value of negative 4 is 4 also. So here's negative 4. What's that distance? Huh? 4. Distance is 4. Distance is always positive. So the absolute value of a number other than 0, let me just write it down. The absolute value of 0 is 0. The absolute value of a number, if it's not 0, other than 0, is a positive number. Okay? So let's go to this absolute value equation. The absolute value of what number is 2? In chat, tell me what you think it is. The absolute value of what number is 2? What do y'all think? The absolute value of what number is 2? Let me see what they say first. Okay, Trillian says negative 2 and David says 2. Are they both correct, or is one incorrect? Okay, you think they're both correct? You think they're both correct? You think David's right? So Trey Lynn, George says that you're incorrect. The absolute value of negative 2 is not 2. So I'm going to ask you, George, tell me what this is. 2. So do you still disagree with Trey Lynn? No, so Trey Lynn and David are correct. So the absolute value of x equal 2, there are 2 solutions, right? There are 2 solutions. And the solutions are x equal 2, and what's the other? X equal negative 2. So there are 2 solutions. You must list both, okay? You must list both. Notice, I want to ask you this. So in this absolute value equation here, how many solutions are there? 2. In that inequality that we just did, number 3, how many solutions are there? How many solutions oh, Trey Lynn, be careful. In this inequality for number 3, how many solutions are solutions to that inequality? David says 1. All right, now remember, I wrote the solution as an interval, right? So negative infinity, negative 5. When I said the solutions are from negative infinity to negative 5, that means any real number that's in that interval. Well, how many real numbers are in that interval? Huh? What'd you say? I can't hear you. Infinity. There's an infinite number of solutions. That's why we put them as an interval, because you can't list them. There's an infinite number of solutions. Negative 5.86 is a solution to that inequality. Negative 7.0008 is a solution, and so on. So there's an infinite number of solutions. You can't list them. That's why you're told either graph the solutions, or put it in interval notation. But when we get to the absolute value equation, there's a finite, infinite versus finite. Finite means you can count. Okay? And so how many solutions are there in this absolute value equation? 2. I can list them. And I did. What are they? 2 and what? Negative 2. That's a finite number. I can list. I can count how many there are. Okay? All right, now, so you're going to use this in your mind when solving the rest of the equations. And you got to show the work. So make sure you show the work like I'm about to do. So we're going to start with an easy one. And so let's say we had this one. 3, the absolute value of 3x minus 2 is equal to 7. The absolute value of 3x minus 2 is equal to 7. Now that one's a little bit harder for you to kind of guess as to what the answer is. Can you tell me what you think one of them may be? There are 2. What do you think one may be? 3. 3 is a solution. 3 is a solution. Here's why. Remember, always check. You go back to the original. What is 3 times 3? Let me write it down right here. Check x equal 3. So always go back to the original. The original is the absolute value of 3x minus 2 equals 7. So we see the variable x, I substitute 3, right? So the absolute value of 3 times 3 minus 2. And I want to see if that's going to equal 7. What is 3 times 3? What's 3 times 3? 9. And what's the absolute value of 9 minus 2? That's the absolute value of what number? 7. And what's the absolute value of 7? 7. And that's what you wanted. So 3 is a solution. Now she guessed at it on a worksheet that says show work, or a test that says show work, or a quiz that says show work. If all she says is x equal 3 and no work, she gets no points. So we have to show the work here. All right, so here's what you're going to do. You're going to use that, and that's not the only solution. Do any of you think what the other solution is? Huh? Negative 3. Let's check negative 3. And the reason why he's saying that, is because he sees 2 and negative 2, right? So he says, well, if 3 is a solution, then negative 3 better be a solution, right? That's what he's saying. Well, let's check it. So is x equal to negative 3 a solution? So let's go back to the original. the absolute value of 3x minus 2 equals 7. And where we see the variable x, I substitute negative 3, right? So the absolute value of 3 times negative 3 minus 2, and we're going to see that's going to equal 7. Well, what is 3 times a negative 3? Negative 9. So I have the absolute value of negative 9 minus 2. What is negative 9 and a negative 2? Huh? Negative 11. Negative 11. And what's the absolute value of negative 11? 11. Is that the same as 7? No. So is x equal negative 3 a solution? The answer is no. Okay? So let's talk about how you're going to actually show the work to get those solutions. Do you remember in that first example I did this? I wrote it down as two, kind of like two little branches here, like two things coming away from each other. That's what you're going to do. And I want you to listen carefully. When I split it apart, do you see absolute value bars in those two equations I wrote? No. So when you split it apart, you no longer write it as absolute value. So the first thing you want to do is to rewrite it without the absolute value bars. Okay? So it's very easy. So listen carefully. So here's what you do. Always make sure that the absolute value expression is by itself. And it is here. See that? The absolute value bars are all by themselves. You have what number on the other side? 7. So that's what I want to make sure I have first. I have the absolute value expression by itself first. So I'm good so far. And then I'm going to split it apart. So now I'm going to split it apart just like this. So once you see the absolute value bars by themselves, you're going to split it apart. All right, now here's how you're going to split it apart. You see that number? Let's go to our previous example. We have 2 here, right? You saw a positive 2 and you also saw a what? Negative 2. So you're going to write 2 equations just like this. On one of them, you're going to have a 7. On the other, you're going to have a what? Negative 7. Just like that. 7, negative 7. I'm going to put this in red. This left side, on both cases, this left side that I have circled, the red, that expression I have circled, do y'all see that was what was inside the absolute value bars? So in that first example I did, what expression was inside the absolute value bars in that first expression, that first equation? Just x. In number 1 here, in our example, I guess I should have, well, we'll leave it as 1. In this example here, what expression is within the absolute value bars? 3x minus 2. And so that's what you write on the other side. 3x minus 2. Oops. 3x minus 2. 3x minus 2. All right? So that's how you split it apart. So when the absolute value expression is by itself, you split it apart. And whatever number's on the other side, you're going to put the opposites on the right side. So this was 7, and this is negative 7. What's inside the absolute value bars, you just write them on the left side. And so notice I wrote the absolute value equation into 2 linear equations. I have 2 linear equations now. And now the rest is easy, because you all know how to solve linear equations. You've been doing that for many years now. On the first one, I'm going to add 2 to both sides, right? So what does 3x equal? 9. And then to get x by itself, right now multiplying by 3, what's the opposite? Divide both sides by 3. 3 divided by 3 is 1. 1 times x is x. And what's 9 divided by 3? 3. And that's that first one that was mentioned. It's the second one that George messed up on. He thought it would be negative 3. So let's find out what it actually is. Add 2 to both sides. I get 3x, negative 2 and 2 is 0, so I get 3x equal, what's a negative 7 plus 2? Negative 5. And then how to get x by itself? Divide both sides by 3. And so here's my other solution. My other solution is x equals a negative 5/3. So those are your two solutions. One's a positive 3, and the other one's a negative 5/3. Let's check the negative 5/3. Let's just verify that's true. So let's just check it. I'm going to go ahead and check it right here. We're going to check x equal negative 5/3. Just to show you what you would do. So you always go back to the original equation. What's the original equation? The absolute value of 3x minus 2 is equal to 7. And wherever I see the variable x, what will I substitute? Negative 5/3. So I get the absolute value of 3 times negative 5/3 minus 2. And I want to see if that's going to equal the other side, which is 7. All right, so you do multiplication first. So on the side, I'm going to write out right here on the side. What is 3 times a negative 5/3? What's 3 times a negative 5/3? Huh? I can't hear you. Negative 15 divided by 3? That's true. And what is negative 15 divided by 3 the same as? A negative 5, right? Negative 5. What I wanted you to remember was many years ago, you learned this. You learned how to reduce. 3 to 3 is 1, 3 to 3 is 1, right? And what's 1 times a negative 5? Negative 5. So you could have reduced first instead of multiplying first and then reducing. So that's negative 5. All right, so now I'm going to come in here. I'm going to ask this. So this is negative 5. So negative 5 and a negative 2. What's a negative 5 and a negative 2? Negative 7. What's the absolute value of a negative 7? Positive 7. All right. So negative 5/3 is a solution. Okay, let's do another one with absolute value. All right, so let's write this as number 2. Number 2, we have the absolute value of 2 minus x plus 2 equal 8. The absolute value of 2 minus x. Trelian asks, is negative 3 a solution? No. Let me go back. So remember, I don't know if that was before we did this or not. So remember, George said, that was before. Okay, thank you. All right. Okay. All right, so we have this absolute value equation. Think about our discussion. Before I split it apart, what must I do first? Get the absolute value by itself. So what should I do first? Subtract 2 from both sides. Very good. So I'm going to subtract 2 from both sides. And so I get the absolute value of 2 minus x is equal to, not a trick question, what's 8 minus 2? 6. Took y'all a while. All right. Now can I separate it? Can I write it as 2 equations without absolute value bars? Yep. So equal. What's going to go on the right side? Okay, so that's fine. You can say 2 minus x, and what is that going to equal? 6. And what's going to be the other equation? 2 minus x equals a negative 6. So 6, negative 6. Very good. And then the rest is just solving this linear equation. So to get x by itself, first thing I would do here is just subtract 2 from both sides. Now be careful because see you're subtracting x, so be careful. When you combine like terms, this is 0, and what's 0 and a negative x? Is it x or is it negative x? What's 0 minus x? Okay, so Trey Lynn says negative x, that's correct. Negative x. So negative x equal, and what's 6 subtract 2? 4. 6 subtract 2 is 4. Now be careful. I have negative x equal 4. You all know how to deal with that now. How do I get x by itself? Yeah, Trey Lynn said right away divide by negative 1. Because negative x is the same thing as saying negative 1x, right? And so if I want to get x, then I've got to divide both sides by that coefficient. So the coefficient of x is a negative 1, so I got to divide both sides by negative 1. A negative 1. And so negative 1, it keeps putting a triangle, but that's a negative 1 right here. Let me do this. Okay. So negative 1 divided by negative 1 is a 1. 1 times x is x. And what's 4 divided by negative 1? Negative 4. So there's one of your solutions. So negative 4 is one of your solutions. Okay, let's do the other equation. All right, good, Trey Lynn. Let's do the other equations. We're going to subtract 2 again, just like this. When I combine like terms, 2 and a negative 2 is 0. 0 and a negative x, just like before, is a negative x. Equal. Now, what's a negative 6 and a negative 2? Negative 8. Negative 6 and a negative 2 is a negative 8. To get x by itself, what do I divide both sides by? Negative 1, just like before. So a negative x divided by negative 1 is x, equal, and what's negative 8 divided by negative 1? 8. And so those are your two solutions. So those two numbers will make the original equation a true statement. And let's just check one of them. Let's check negative 4. Let's go back and check negative 4, just to show you what to do. So let's check x equal negative 4. So it goes back to the original. And my original is 2, the absolute value of 2 minus x plus 2 is equal to 8. That was the original. So in place of x, what will I substitute? Negative 4. In place of x, you'll substitute negative 4. So I get the absolute value of 2 subtract x. X is a negative 4. I'm putting that in parentheses. So you're taking the absolute value of that. Then whatever that is, you're going to add 2. And then you want to see if that's going to equal 8. Okay? So let's look at what's inside the absolute value bars. 2 subtract negative 4. I want you to think about this. 2 subtract negative 4 means the same thing as 2 plus what? 4. So remember, with subtraction, you add the opposite. So 2 subtract negative 4 means the same thing as 2 plus 4. And what's 2 plus 4? 6. So I'm taking the absolute value of 6, and then I want to add 2 to that. What's the absolute value of 6? And what's 6 plus 2? 8. So x equal negative 4 is a solution. Okay? Let's look at this one. Yeah. No. I was just checking, just saying what you would do with some of those. Some of those, like what I did here, some students have trouble when you're subtracting a variable and you got to substitute a negative. So that's why I checked it, just to show you what you would do, and to remind you about some things you learned in the past about subtracting integers. You always change it to an addition problem. You add the opposite. So 2 plus, and the opposite of the negative 4 is a positive 4. So there's just a couple of things I wanted to remind you about. But no, you don't have to check. So in terms of your work on the worksheet, you just show this. That's all you show, okay? So this would be show on worksheet. Yeah, so let's suppose there were just 10 altogether. And so of those 10, I'll just keep the better 5. The highest 5. All right. So I give a lot of worksheets, and many students, they have lives, other things that happen in life. And so you can't do everything on time. So that's why I draw the path. But you still go back and do those worksheets because it could be on a test or a final exam. Okay, let's do one more. Number 3. We have 2 times the absolute value of x minus 6 is equal to 5. So 2 times the absolute value of x minus 6 is equal to 5. Now be careful. Many students want to distribute that number because they think of this. They in their mind, they think like this: 2 times in parentheses x minus 6. Now in that one, that is definitely I can use a distributive property here because that will be 2x minus 12, right? But you got to be careful with absolute value bars. You cannot always distribute with absolute value bars, so you got to be careful. So if this was a -2 in front, you wouldn't want to do that. Okay? I'm just letting you know, if this was a -2, don't make the mistake and distribute. You got to be careful. Now I will do it both ways. I'll show you what I mean. So you got to be careful. Don't mistaken this right here with parentheses. That's not the same thing. Absolute value bars and parentheses mean 2 totally different things. Okay? I'm going to show you one way, and then I'm going to do it to where if you distributed, what would happen. Okay? All right. So here's the way that mathematically you should do it. Because if there was a negative in front, it would still work. All right, so remember a while ago I said you want to get the absolute value bars by itself? Well, right now I'm multiplying this right here by what number? 2. So I'm going to divide both sides by 2. Divide both sides by 2. So the 2's divide out, just like this. And I get x minus 6 equal 5 halves. Now I have a fraction, that's fine, I can deal with fractions. And then finally, what's the next step? How to get x by itself? Add 6 to both sides, right? And so when I combine like terms, I get x equal 5 halves plus 6. Now you have access to a calculator, but I'm going to do this by hand just to remind you what you would do. So when adding fractions, and I'm going to write 6 as 6 over 1, when adding fractions, 5 halves plus 6 over 1, you got to first of all find the least common denominator. What's the least common denominator? What's the smallest number that 2 and 1 go into evenly? 2. Least common denominator is 2. So now you're going to write equivalent fractions. So you want to write an equivalent fraction of 5 halves with the denominator 2. Well, the denominators are the same, right? So that means that 5 halves is equivalent to itself. So there's nothing to do there. 5 halves is equivalent to 5 halves. But in that other fraction, you have 6 over 1. You want to rewrite 6 over 1 as a fraction with 2 as the denominator. And remember what you did. You said 1 times what is 2? 2. What I do to the denominator, I do to the numerator. 6 times 2 is 12. So 6 over 1 is the same thing as saying 12 divided by 2. And now, since the denominators are the same, you add their numerators. What's 5 plus 12? 17, and then your denominator is 2. So the answer is x equals 17 halves. That's your solution. Okay? Say again? You can write as a mixed number. Yeah, but don't write as a decimal because it doesn't always terminate. This does, but if this was, let's say, 5/3, 5/3 doesn't terminate. So you just leave it as a fraction or a mixed number. So if you want to put it as a mixed number, that would be, remember how to do this. You're going to say 2 divided into 17 is 8. 8 times 2 is 16, remainder 1. So it'll be 8 and 1/2. 8 and 1/2. Okay? Now, just to let you know, I'm going to rewrite the same problem just to show you. If I had distributed it, now notice 2 is what kind of number? No, okay, yeah, it is even, but that's not what I wanted. 2 is what kind of number? I'm going to say it this way. Is it positive or negative? Positive. All right, since it's positive, if you do distribute, let's see what happens. If I distribute, I get the absolute value of 2x minus 12, right? Y'all agree? 2 times x is 2x, 2 times -6 is -12, yeah? Right? Okay, equal 5. Now let's break it apart. Oh, I'm so sorry. I messed up here, did I? What did I forget to do? Yeah. All right. So yeah, so remember I wasn't paying attention and this is an absolute value equation, right? So I should have said the absolute value of x minus 6 equals 5 halves, right? And then split it apart. So let me go ahead and, there's too much work here, so let me go ahead and do this. Let me do 3 again. 2 times the absolute value of x minus 6 is equal to 5, right? We divided both sides by 2. Y'all remember that? 2's divide out. And you get the absolute value of x minus 6 is equal to 5 halves. So that's where I forgot to bring down the absolute value bar. So it's very easy to forget when you have a lot of stuff all over the place. But y'all see that's what you need, right? Then we split it apart. So we have x minus 6 equals 5 halves, and what's the other? X minus 6 equals what? -5 halves. Adding 6 to both sides, we get x equal, we've already done this one, 5 halves plus 6. 5 halves plus 6 is the one we just did. Y'all see that one? So that was 17 halves. All right, let's do this one. Add 6 to both sides. So I have x equal. All right, now look, -5 halves plus 6 over 1. See, this is -5 halves. Over here, it was what? +5 halves. So this is negative. The process is the same. What's the LCD? 2. So you want to write equivalent fractions. -5 halves is equivalent to itself. Now 6 over 1, just like we did a while ago, is equivalent to what number divided by 2? 12. What's a -5 and a +12? +7, very good. So we get 7 halves. So those are my 2 solutions. So 17 halves and 7 halves. So I apologize for that. I had so many things here, I just now lost it. Well, that's great. Here it is. So I have so many things there that I forgot to bring down the absolute value bars. Okay, so now I want to go back to the one we had here. So I'm just going to cross this out. And we're going to do the same problem. And I want to show you something. So this is number 3 with a star, so it's number 3 again. Okay, if you had distributed, it's a positive 2 out there. If you had distributed, let's see what you would have done. So if you distribute, you get the absolute value of 2x minus 12 is equal to 5. Now we split it apart because the absolute value is by itself. I say 2x minus 5 equals what number? 5, right? Not 12. I'm sorry, 2x minus 12. Minus 12 equals 5. And then 2x minus 12 equals what number? Negative 5. Okay. Adding 12 to both sides. Adding 12 to both sides. 12 and negative 12 is 0. I get 2x equals 17. What's the next step? Divide by 2. And so I get x to be 17 halves, which was what we had here, right? Okay, let's do the other one. Adding 12 to both sides. Adding 12 to both sides. I get 2x equals, what's negative 5 and 12? What's negative 5 plus 12? 7. Divide both sides by 2. I get x to be what? 7 halves. So if I distributed, would I get the same solutions? Yes. In fact, it's easier in this case to distribute because you don't have to fool with all those fractions. But what happens if there's a negative in front? So I'll make it easier to where we won't have any fractions. So let's look at this. This will be number 4. I just want to show you something. What if I had 2 times x plus 1 is equal to 6? Okay? Now there's a negative in front. You got to be careful, because you're already dealing with the absolute value bar. So the correct way is to divide both sides by that negative 2. So let's divide both sides by negative 2. So I'm going to write this over. Divide both sides by negative 2. Negative 2's divide out. You get the absolute value of x plus 1 is equal to what number? Negative 3. Okay, now, listen carefully. The absolute value of a number is always going to be either 0 or what number? Positive. The absolute value of a number is either going to be 0 or positive. Is it ever going to be negative? No. Remember we did those examples, absolute value of negative 3, absolute value of 4, always positive. You get this case here, and you could see this on Newton Alta or a worksheet. It's not good. I'm not going to give you this on a worksheet, but you could see a Newton Alta. I have the absolute value of this expression equal to negative 3. Is this absolute value, whatever that is that ever going to be negative? No. So right away you can say no solution. There is no real number. There is no real number that you can substitute into that absolute value expression that will be negative. Okay? So whenever you get the absolute value, and you don't have any like that on the worksheet, but if you have the absolute value of an expression equal to a negative number, there's no solution. Nothing will work. Okay, now listen carefully. What if I had this, number 5? What if I had the absolute value negative 2 times x plus 1 is equal to a negative 6? Just how I put negative 6 on the other side. Let's do the same thing. Let's divide by negative 2, okay? Divide by negative 2, both sides. The negative 2's divide out. I get the absolute value of x plus 1 is equal to a negative divided by negative is a positive, so that's a positive 3. The absolute value of an expression equal positive. Is that possible? Yes. So that's where you're going to split it apart. You're going to find the solutions. In fact, you can tell me right away the solution is, what's one of the solutions? Heck, the absolute value of x plus 1 equal 3. What could x be? 2. 2 plus 1 is 3. Absolute value of 3 is 3. So that's one of your solutions. You could positive tell me the other. Negative 4. Negative 4. Negative 4 plus 1 is what number? Negative 3. What's the absolute value of negative 3? 3. All right, so let's split it apart. So when you split it apart, you're going to say x plus 1 equals 3, and then x plus 1 equals a what? Negative 3. And then you subtract 1. So what's one of them? 2. And then you subtract 1. What's the other solution? Negative 4. Okay? Now, the whole point of this was to tell you this now. Okay, listen carefully. Okay, so listen carefully. You remember in one of the examples, we went ahead and we distributed? Remember that? The previous one? Let's see what happens if I do it here. Let's see what happens if I do this here. So let's see what happens if I distribute the negative 2. I get the absolute value of, what's negative 2 times x? Negative 2x. What's the absolute value of negative 2 times 1? Negative 2, right? Equal negative 6. Okay? Now, if I break it apart, in fact, this is our discussion a while ago. I just want you to think, okay? Right here, we have the absolute value of an expression. We have the absolute value of an expression equal a negative number. Is that possible? No. Right here, I have the absolute value of an expression equal a negative number. Is that possible? No. So if I distribute the negative number, it no longer makes mathematical sense because I have a absolute value expression equal to a negative number, and I know that can't happen. So that is why, if on Newton Alta, and I don't think I put this on your test, on your worksheet, if you have a negative in front, you don't distribute. Don't distribute. Because if you do, it no longer makes mathematical sense. If it's positive in front, could you? Yes. You could if it's positive in front, you could distribute. But if it's negative, you can't. Okay? But I think the ones in your worksheet are like the previous ones we did, numbers 1 and 2. They're more like that. Okay? But don't if it's negative in front, don't ever distribute, because then it's no longer making any mathematical sense, because the absolute value of an expression can never be negative. Okay? Okay. So real quick, let me just write it down because there's not that many of you. So make sure, Traylyn and David, make sure you go in Canvas and mark your attendance. Mark your attendance, and I'll put the video on Canvas, all of you, tomorrow. So let me just quickly write down the first name. So Traylyn, David. Okay. Just tell me your first name as you go. Madison? Okay. Cornacia? Kiera? Okay. Kiera? All right. Lenore? Okay. And then George. All All right, guys, thank you. Just keep working the worksheets, do what you can, make sure you continue working your novel. You too, bye, be careful in the rain. All right, Traylene and David, I'm about to, shut it down.
I have a question.
Yes.
I am so confused.
Uh-huh,
Here,
let's go right there.
what I'm doing,